Good day everybody and welcome back to the channel. I'm just getting a little bit of research done here. So what I've been working out is what I'm going to need to boost this transformer here. Let me just take the focus lock off. There we go. So this is a 750 VA transformer. Now the thing to consider when adding another transformer to boost the primary voltage is the transformer doesn't need to be the same VA as that. What you need to work out is the percentage of the voltage that you're making up with the transformer that you're boosting. You need to be able to handle the VA of that percentage of the voltage for that transformer that you're going to use. Also, the winding must have, the same current capacity or greater than the winding on the primary that you're going to boost. So with those two things in mind, this is 1.25 mil winding, and what I want to use for either two transformers in parallel is going to be this. Okay, I really can't get that to focus. There you go, 2.5. So double, right? 160 VA is more than enough, and that can handle the ampacity, but the problem is it's only 9 volts. So this is where it gets interesting. I've got quite a lot of different options here. I've got an old Atco 240 volt, 12 volt, it's 500 VA. This is way too big for what we need. This can supply 41.7 amps. I do not need two windings that big. One winding that thick would do, but again, we would need to put these two windings in series to get, the 24 volts. I'm thinking I'm going to need at least 24 volts anyway. So here's what I'm going to do. The closest thing I've got at the moment, without custom winding something, which is what it looks like I'm going to have to do, is this one. This is 16.5 volts, 7.5 amps. It's a 250 VA job. We've got two separate windings here, and I'm just going to put the phone down so I can measure. If I can find somewhere to get the caliper on. Thinking this might actually be a bit too small. It does look like the same thickness of winding. Yeah, no, it is. That's 1.25 mil. Or is it? Here's a bit I can get to. All right. No, that's actually 1 mil. That's just over 1 mil with a bit of plastic either side of it. So this is 1 mil. God. All right, this isn't going to work. Jeez. All right, let me have another look. All right, well, it's either pick one of these two. That I'm going to clean up if I end up using it, because this was outside for years. Not in my place where I found it. And then I've used it too for various things over the years. This one's alright. Anyway, I'm going to try this first. This is 9 volts, 17.8 amps. That will do the job for both the transformers. I don't think 9 volts is going to do it, but I'll give it a try. So let me prepare these two ends, and then we'll get this some power and we'll wire it up in series with the primary of this transformer to give it effectively line voltage plus about 9 volts. Alright, so unfortunately with an extra 9 volts we only have 45 volts. I do have 1.3 ohms on each side, of course, not the 1 ohm on one side, so that's not going to cut it. 43, 44, 45 and a half, 7 and a half. We need about 18 volts. Alright, we might be in luck because I need a little bit less than 9 volts to get 47 volts on each winding. And this is 16.5 volts a side. I just cut a little bit of plastic here just to expose that one bit of the secondary where it's a little bit lower than the rest. Sorry, I realised that you couldn't see it on camera. And I've put the caliper around it now without the plastic there. I know the caliper's flat, but if we look in the end of it, we can see it's actually the same. It's 1.25 mil. We can use this. So the beautiful thing about this is it's got 2 separate secondaries, one for each transformer. So this amp's going to be freaking huge, or very densely packed. That's going to be our boost transformer for both of these. Look how close it is. Look how close it is. Please don't ever hook stuff up like this. This is just for testing purposes only, alright? But 46.9, come on. Let's just give that a bell, eh? Let's see. Let's come back over here. Go to DC. Jeez, I use this meter so infrequently I don't even know how to use it. Let's see what our DC rail drops do. Hey, that does it. There you go. Now we're getting what we need out of our transformer. And the reason why we've got more power is, as I was saying in yesterday's video, because I'm using the whole 1.3 ohms of winding on each side. So if I was just putting 240 in, the transformer would make... Patch! Oh, let me shut the door. Right, so yeah, if I was just giving it 240 volts, we'd have a less powerful transformer, but because we've boosted the voltage, the extra voltage makes up for that extra 0.3 ohms. So, problem solved. I'm very happy now. We'll have 63 volts secondary. You know what? That also means that those resistors that I changed on the driver board from 33k to 27k to make up for the 63 to 55 volt secondary after rectification voltage change would have to get changed back. But I've already thought about this. I'm not going to, because I don't want less than 2 milliamps going through the diode string. It was only at 2 milliamps. If I leave it, it's going to be about 3 milliamps. That's fine. What I want to do to make up for it, you know what, let me just go get the board in question and I'll show you. Alright, so on our bias string we have 2 500 ohm pots in series with a 560 ohm resistor, and that is in parallel with these 220 ohm resistors. I'm going to change this 560 ohm resistor to a 470. The reason for that is that will allow me to turn this pot down enough to bring the bias back down whilst still having about 3 or 4 milliamps going through here with the increased rail voltage and 27k current sourcing resistors. So that's what we're going to do now before I forget. Like right now, I'm going to get 470 ohm resistors and we'll change those two 560 ohm resistors to 470. So I'll be back in a sec. Alright, I've packed up a few things too just to make some space. I have to say, honestly, personally, I would rather just take off 0.3 ohms off each winding, but I'd have to rewind the transformer to do that, and it's just so much work, especially on one of those toroidal style transformers, because you can't just take a bobbin off and wrap around it and set up a jig with a drill or something like that. You literally have got to sit there and feed one turn around, pull it through, feed it through. I'd be there for hours, literally. That's why I've decided to boost it, you know. If anyone has a way of making a jig that's easy to wind toroidals, leave it in the comment section. I'd be interested in looking into it, and I'll give it a go if it seems easy enough, but I don't think it is. That's why I'm doing this, just in case you're wondering. I would rather run my transformer with a more saturated core, especially for an amplifier, but you know, it is what it is. Anyway, we've effectively done that anyway. It's just going to take up a lot more room. I'll go get a couple of 470 ohm resistors in the other output section. Alright, I've got the resistors, so let's get to swapping. So I've just grabbed something else, and this will make a little bit more sense to you because I've already had a look at this. Some of you may remember the amplifiers that I stripped down that was all just made with point-to-point wiring. Here is the same thing again, a 500 ohm pot with a 560 ohm resistor, and we can see the pot is referenced to where it's connected almost at the full travel. So with the 33k resistors and this arrangement here, I needed it about there, right? With 27k resistors, it's going to be, well, here's the thing, because I've increased the rail voltage back up to 63, I'm going to want to be able to turn that pot down a little bit, maybe more, which is why I'm going from 560 ohm to 470. I hope that makes sense. It just means that this is going to be more towards the center, and if I do have to go more that way, I will have the range of travel that I need. Alright, I've just come back from J-Car. I've just stocked up on TO220 heat sinks of different shapes and sizes because there's many. Have a look at this. This is the crazy thing about my lab. Every time I go to get something out of my vast collection of components, I'm either running out or don't have it. It's absolutely insane. Anyway, I've got a few projects that are going to require TO220 heat sinks coming up, so I stocked up on them. A few different styles. I was literally out of 22 mic tantalums. Sorry about the light, as you can see. So I've got some more of those. Got some more ferric chloride, 2 bottles. I know I grabbed a couple. Oh yes, those bridge rectifiers that I was running out of. I've refreshed them. I can't think off the top of my head, but there was a couple of other things that I'd run out of that I had written down on a piece of paper, so I've got them. There was some stuff that I had to order off of AliExpress as well. I did that a week ago. I think I've already mentioned that. So anyway, point is, I've already got everything I need for this project, and by the time this is done and I'm working on the next project, everything will be here for that too. So we're going to be building a lot of stuff. There's one thing after another coming up now. Basically starting here and continuing here. I've actually been stocking up for quite some time in order to have everything that I want for a number of projects, and I'm basically there now. So that is cool. Anyway, as you can see, I've got the 470 ohm resistors ready. I've just turned the soldering iron on. I'm just waiting for this to come up to temperature. 325, 335, 345, 350. All right. I'll just tin these resistors up very quickly. You know what? I'll go 370. I'll do this off camera and I'll come back in a sec. Yes, that's better. All right, they're tinned up. Now, we'll get these 560s off of here. I'll just get the rest of them off of camera. All right, that's the resist. Ooh, resist is removed. So now, wrong way. We'll get the new ones on. Once again, I'll do the rest of these off camera. All right, I'll get the rest of these done and I'll be back in a sec. All right, so that's 470 ohm resistors fitted. So I'll go put these back over the other side of the lab. I'm now happy with the power supply voltage and the bias string. All right, well that brings me to these boards. So now we've got our functioning circuit and we know it works. I can put this onto these and get these made up. So I'll do that now. And then we can move on with building the power supply. Fun. I tell you what, I really want to rewind the transformer, you know, instead of having another huge transformer, just because of the weight and space purely. But at the same time, I can really not be bothered trying to rewind a toroidal transformer. So yeah, it is what it is. Oh well, I'll get these made up. Alright, I've just done some testing. Now I wanted to mention something about these fans because I keep forgetting to mention it. With the voltage at 15 volts, I've extensively tested these fans at 15 volts. They will run at 15 volts and the motor doesn't even get hot after half an hour. I've felt both sides of the motor and it doesn't warm up at 15 volts. This model is the YX2523. JCar sold a few different models of these fans. That's why I'm telling you which fan this is, because this one takes a beating. I don't know if the other ones take the same beating. So it's YX2523. Something else to note is that this fan consumes more current at 12 volts, not 15 volts, than what it says. It says it only takes 200 milliamps. I've tested some of these to take 300 milliamps. Well, I think all of them. I think it was 300. You know, let me just get the multimeter and I'll verify that for you guys. I'm pretty sure it was one of these fans. I can't remember now. We're at 12 volts. Yep. Yeah. So I'm wrong. it's not these fans. Okay, that's interesting. And that's with the most load on it because it's got air moving through it. A fan will always take, or any motor has wind resistance on it, it'll take less power when you block the airflow to it because it's got no air going through it anymore. You'll actually hear it spin faster. Actually, a common misconception, a lot of people think that when you block the flow to a fan and it spins faster, they think it's taking more power and it's working harder. It's actually working easier because it's got no air going through it. That's why it spins faster, because there's wind resistance. Anyway, just wanted to point that out. You see we're flat down, we've got 196, 195 milliamps, and with it up, with air going through it, we have, okay, less. That's a little bit odd. That's not normally how that works. Anyway, so, what am I going to do? Oh, that's all right. I wanted to show you the airflow. Oh, actually, you know, one more thing I want to check is what the current draw is at 15 volts. Might as well whilst we're here, eh? Just over 15, right on 15. So that's still quite good, 260 milliamp. Alright, so it must be another fan that I measured that had a higher current draw. It's obviously not these ones. Ah, whoops, you know what, I need this plugged in. So for this test, I'm going to have the fan at 12 volts, not 15. Even though it's going to be able to get up to 15 if the amplifier gets too hot, in an attempt to save the amplifier from turning into a pile of smoke. I think that's a good idea. Whoops. So fan's back at 12 volts. Bring the heatsink in situ. And as we can see, with the one fan in the middle blowing the air into the heatsink, there is no air coming out the top. Now that's quite impressive, considering. Look at that. If anything, it's actually sucking a bit in. Look at that. It is. So the draft that's going through the heatsink and coming out the end here, as the air is moving through, it's actually pulling more air in the front. That's actually really cool. Because not only you have the airflow from the fan, but you actually have an additional bit of airflow that's created for free just from the current. Look how much air is coming out the side. Yeah, it's quite impressive. I don't think I need 2 fans per heatsink. I think one is more than enough, given the fact that we've got an actual speed controller and this much airflow, and the air is very linear like this. You know, one thing I'm worried about with 2 fans is maybe just running bias current, or the heatsink, you know, just at a very warm, not hot temperature. One fan might be running before the other, which is going to inherently cool down the PNP or the NPN side more than the other and cause linearity issues, and I don't want that. So we're going to go with one fan. As you can see, we've got absolutely amazing airflow, and that's at 12 volts. I'll turn it up to 15 and see what we get. That's wonderful. There's so much air coming out of here, it's not funny. Absolutely amazing. Well, that's that problem solved. So 1 fan per amp, and the other thing that's good about that is, you know, after I boosted the voltage to the transformer, you know, we didn't have our fan circuit rail voltage, the 15 volts, drop below 15, even with 2 fans. So the thing is, we still didn't have a load on the amplifier. Now, I'm confident that there's enough power there now, but definitely with 1 fan, there's enough power. So that just rules out all problems. Also, that couple hundred millivolts of ripple, which is nothing for a fan controller, is going to be halved with 1 fan. So everything works out in the fan department. So I don't know where my other fan's gone. Over here, okay. So basically everything you see on the table in front of you is the fans circuits for both amplifiers. So what I'm going to do now is I'm going to transfer this onto those 2 boards, make the boards up, and then populate them. And then we'll get to building the power supply. I can't wait. The only thing that I'm not happy about, I'll say this, is, as I said before, the fact that I now have this whole extra transformer. I really would not mind, you know, having 1 ohm on each side, as I said before, and having the transformers run more saturated, but I couldn't imagine trying to unwrap the secondary with it on the spool like that in the toroid, and then having to unwrap some of the primary, and then I'd only be measuring resistance. I'd never actually know exactly how many turns, you know, so I'd still have an uneven number of turns on each side. I'd actually have to measure the secondary voltage, take a turn, like when I got close, you know, take a turn off, measure the voltage, take a turn off, measure the voltage until it's exactly the same on both sides. I'd rather just stick another transformer in there. I've been looking at cases, and I think I've found the case that I want to use. The only problem is it's very expensive. The case itself, it's only, I think it's $150. The problem is, with shipping, it is $280 or $265, something like that. I was looking at a few different cases, so it's hard to remember all the exact prices. But that's kind of money I can't spend at the moment. I'm trying to save money. I have things that I need to sort out in my life, and I've already spent a lot on components recently, so I'm trying to avoid buying that. I'm going to continue looking for another case, but remember how I said I want to repurpose that Sony Mateki receiver that's just completely inadequately sized and rated? Well, I'm thinking about taking the front off of that and just building my own front for it and using its massive case to put all this stuff in it. And then when I do that amplifier, well, I guess I still have to work out a case for that, but we'll come to that when we deal with it. It's that, or this will have no case for some time. So I've got to decide upon that. I've just been thinking about how I can make this video a bit quicker, and I think what I'm going to do is I'm going to do these 2 boards with the input boards that have to house the NTC and the 100 nanofarad X2 cap. That way I don't have to do 2 separate etches. So I'll go make up another plan and cut out 2 more PCBs. I've decided to change the 100 nanofarad 100 volt capacitors that are going across the transformer secondaries to 100 nanofarad 400 volt CBB style caps. These will handle high voltage spikes. So, you know, if there's a spike on the grid or a spike from the transformer being powered up on a bad part of the wave, the little 100 volt mylar caps that I put on there won't break down. We'll be using these. These shouldn't break down. So I just wanted to point that out. If anyone's curious, the rectifiers I've just covered with heat sink. What I've done is I've got a screw with a washer on that end of it, and then another washer. And the rectifier is just going to go on the heat sink, like so. Screw through hole with the washer. And then I've got to cut the screw down a little bit on the other side and put the other nut and washer on it. So that's how the bridges are getting done. Alright, I actually found a couple of screws that were the exact right length, so that's good. That's the two rectifiers on the heat sinks. That's how they're going to be mounted in the amp, just sitting on the bottom of the case. So there we go. Alright, that's one PCB ready for etching, and these two that have an NTC in series with the line and a cap in parallel. One board for each transformer. Even if I put both these amps in one big box, I'm still going to have two power switches, so I can use one amp if I want, and I don't have to have two huge amplifiers running at the same time. So yeah, two of everything. What else have I done? I've got a couple of 10 nanofarad capacitors here ready to mount across the switch contacts. I need to make up something for these transformers. I'm thinking about putting a strip of board across here and soldering all the outputs to the board so it just sits there, and then I can mount these capacitors on the board and then solder my wires from the board to my amp. It'll keep it all nice and neat and allow me to mount the capacitors right up next to the transformer. So might make up another two boards yet on top of this, but this will be all the little bits and pieces done today, and then all that we'll have left to do is design preamplifiers. When I say preamplifiers, I mean an input stage, a VAS, an entire front end for an amplifier. But yeah, tell you what, having this scrap circuit board box over there comes in real handy. I realise you can't really see too well from over here. I'll go get it. You know, I still got some big pieces left as well, but the thing is, I always put all my offcuts in this box, and most of the time when I need to make up a little board, I've got something in here to grab that's either the right size or close to it. And again, I needed a couple little strips. That is literally what I need. I'll take those two because they're better, you know. And then I've still got all these pieces in here. I'll use them to make breakout adapters for SMD parts and stuff like that. They all get used eventually. Alright, maybe some bits will end up getting tossed out, but you know what I mean. Alright, I marked up those strips with some lines. So they basically, I'll just take this tape off that I put around it and move these a little bit more in, and then that will just perfectly line up with the 4 wires on each side and give me a nice mounting place for capacitors and more wires. So that works out good. Gives me a use for the scrap too. Well, that's all the boards done. I know they're slightly different to each other. I do this freehand, you know, and after I've done the first board, I try and copy the second one from it. It is what it is. They're fan controllers. You know, the traces could be 100 times thicker or 100 times thinner and it would still work. So, you know, it would work with or without a ground plane. It really doesn't matter. But anyway, I try my best. Time to etch all these boards up. So that's what I'm going to do. I'm not going to do too much more tonight. It's already 11:30. I don't mind doing another hour and a half or so, and then I'm going to go to bed. I've been going to bed earlier and earlier, probably about the last 7 days now, actually. I'm getting my sleep patterns back in check because they have not been in check for some time. So I think I'm just going to do 2 at a time because it's a little bit hectic having a whole load of boards in the one container going at once. So without further ado, I'm going to drop in these two. I think what I'll do, I know what to do. I hate the table, it's ugly and dirty. I'll put this here, move that off to the side. That works good. And then I can put this here. Bring this here. Turn it on. I got to remember to not let it get too warm this time because the marker lifts up. And we'll drop this in. Cool. Can you imagine spilling this stuff everywhere? It is nasty. It's like betadine. I'm not sure if that's in, oh crap. I'm not sure if that's in other countries or if that's an Australian thing, but it's an antiseptic. But it's very similar to betadine, but with like a yellow in it instead of the more darker orangey brown color that betadine has. But it reminds me of it so much. Anyway, I'll pause the video. I'll come back when this is making some progress. I'll basically just do some little time-lapse bits of the board progress, and then I'll clean the boards up at the end and give you a look. I am going to populate these two boards tonight, so my goal is to get these etched and the two little fan controllers populated, and that's it. I mean, if I go really quick and I've still got say half an hour left or something, then I'll do those boards on the transformers and mount these capacitors and the capacitors on the switches too, but I can't see that happening tonight, so I'll just see how I go. So I put in an order yesterday for something. I went through a factory that custom makes low induction resistors, huge resistors, 500 watt resistors. They actually make them up to 1.5 kilowatt. I just decided upon 500 watt versions. So far what I've done is I ordered four 4 ohm 500 watt resistors, because that gives me the option of making 4 ohms, 2 ohms, 8 ohms, and well, if you want to put all 4 together you could, and 3 you could make other combinations too. But I'm going to buy another 4 in the future, because what I intend on doing is maybe another 2 or 4. I've got to do the math on this. I've got a load bank project, which is basically, I've actually already started building some of it, and the rest I've just got parts off to the side. I'll bring some stuff over to show you the concept. So basically I've got this box, and what I want to do is I want to mount all these banana jacks to it. And from that box will be some cables going to these huge load resistors. And then I have all these jumper jacks. So what I can do is I can just change the position of the jumper jacks in the box, and I can change the load resistance of the bank. And obviously the other thing the box will have on it is a couple of banana jacks that aren't for jacks but to attach your load. So, and some BNCs to look at across the load. So that's a project that's coming up. It's been something that's on my to-do list for a long time. It's just that I've been waiting for a long time to find somewhere to get the resistors from without paying through the roof, and to be ensured that they're the proper thing. So, you know, it just took me a while to work out how I was going to do that. and I also had to get the money too for it. So that ordered. They should be here within 2 weeks at the most, possibly quite a lot sooner. Could be here in like 5 days. Seriously. I've also ordered a couple of other little parts that I don't want to spoil. I'm going to do some video series coming up on different little parts, from, switching regulators to linear chips, like, reference ICs and linear regulators and stuff like that. I want to do a series of little videos on building some circuits up with just various parts, basically. So I've ordered a few more things that I wanted to use. I want to do some videos on like LM2576s, for example, and I wanted to do some videos on some devices that we'll make ourselves that will be free running oscillator based and stuff like that. I wanted to do some charge pump ones, so I got some ICL 766Os. I got yesterday I also ordered some MCP34. Let me just look at the number, sorry. MC34063. I believe that's a little boost converter IC. I got something else I ordered, the same thing to go with this video series, was a Linear Technologies part that I found some old stock of. That's also a regulator IC. I got some reference ICs. I got a few things I've got planned for this small series of videos that's coming up, but yeah, I just wanted to let you all know that that's coming, and some really hefty resistors to build a load bank, which of course this is the perfect time for it to be arriving as I'm building amplifiers. So everything is coming along quite nicely. Also, these boards are coming along quite nicely. They're probably about halfway done. I've been moving the liquid around and I've turned the temperature off before it got too hot. But you've got to turn it back on now. That's just about done. Just a few little bits left on it. I would try and show you more, but that is really going to run out the tray. Alright, well, I'm just bringing this back up to a bit more temperature. I'll pause and I'll be back soon. I'll tell you what, this is not going to plan. I am falling asleep, which is a good thing, but I'm going to get these boards done that are in here, and I'm going to end the video here. There is no way I'm going to get those other 4 boards done tonight and these ones populated. That's just not going to happen tonight. Sorry to say. Alright, that's the first 2 little boards done. Time to turn that off again. Let's get them cleaned up. Alright. There they are. 2 fan controllers. Well, against my better judgment and power of coffee, I am continuing. I still don't think I'm actually going to populate those 2 boards tonight, but we'll see how I go. I just really want to be able to get basically everything in terms of the power supply and what I already have built finished and powerable by tomorrow. At the worst case scenario, I mean, I really want to be designing the front end by tomorrow and having it ready to power up. Not the entire thing, at least just what I've got, the output stage and the power supply. But I want to see that biased up, accepting a signal, amplifying it, not doing any funny business, thermally tracking, no cross distortion, all that sort of stuff. I want to see the output stage doing that, by tomorrow, and also at the same time have a start at least on the front end. So I am pressing on. Since I am doing more boards, I've decided to just do stuff in the meantime. So I've gone and fitted the capacitors to the back of these switches, literally to the back, for 2 reasons. I don't want it in between the pins, because if it somehow ends up sideways and, I don't know, a bit of plastic rubs through, it could potentially form a short. I mean, you've got the whole lead that goes through the package, if you know what I'm saying. Anyway, also, you don't want it sticking out sideways, because I've got to put the switch in the cutout. I'm not going to solder them now. I'll solder it when I put the wires on it, so I only have to apply heat to it once. You're not supposed to even solder these, but if you're quick, you can get away with it. I've started forming up components, so these I've already formed and cropped. Same with them 2. Now I've just got to start on them components, and then I'll move over to those components, and last but not least, these components. So still making progress. I'm still doing a lot better than what I've been doing. I mean, for example, if this was about a week ago, it would have been closer to 4 or 5 in the morning by the time I had got towards the end of what I was doing and packing up. That's how bad I'd gotten. So yeah, I reckon an hour tops I'll be in bed, so it's alright. Maybe 150. I'm aiming for 150. Okay, so that's another 2 boards done. I think I'm just going to do them all. I have also finished all of the components ready. Bloody auto lock. As you can see, I've cropped all the legs to shape and size for everything, except for those capacitors. I guess I can do them now because I know where they go. They've just got to go across the outer 2, so yeah, I can do them too. Yeah, so basically ready for assembly. Let's clean these up. I can't lock the image right now. If I do, I'll show you what happens. It's either dark or it's swamped out, or it's dark. I just can't get it right. So I'll just leave it on auto right now. It's only because of this reflective surface. I have the same problem every time I do that. So my apologies. I mean, half the time I forget to lock the bloody thing anyway, and that's just my fault. So I mean, I'm probably worse. My apologies again. That is the most oddest thing ever. Oh, there they are. Went to grab my Stanley blades and they weren't there. I've had these for years. I just want to scrape this label off the back of the board. That'll do. The reason being, it's full of copper residue and ferric chloride, and I just don't want it on the back of the PCB. Not even so much for electrical reasons, just because it's yucky, but you know, it's not good to have that there really electrically either, I guess. Anyway, let the removal process begin. I've been looking at cases and I'm thinking I might just fork out and buy one. And I've been looking at this particular one that's massive. It'll let me fit all the transformers in it and both amp modules, and yeah, make up a nice front panel to, you know, have, you know, a gain and power and everything for the two separate amplifiers. I'm thinking about that. I'm tossing up between that and still doing it in two separate housings. So we just have to see what I decide upon. I don't want to reuse that Sony case for these amps. They're just too good of quality to put in a piece of shit equipment like that. I just can't. I can't do it, you know. Like seriously, just my power supply's worth more than that whole freaking thing. I don't like putting something good in something crap. You know what I mean? Especially if I'm building it for myself and I'm going to keep it for a while and all that sort of thing. You know, yeah. Alright, well, that's those boards. I don't know why I'm just standing here talking. Let's put the heat back on and drop another two boards in. Cool. So these boards are just for these. So the NTC is just going to go like that, and the cap's just going to go like that. So nice and simple. Well, I'll let this go and I'll come back in a little bit again. Well, that's those two done. So our power comes in here and goes out there. Putting them back off to the side. How are we going here? I'm actually surprised this ferric chloride hasn't died yet. Strange. Sometimes I get more batches than other times out of the same amount. I don't understand that. It's almost like these bottles are mixed in different concentrations. Unless I'm just impatient sometimes, but it feels like... No, it can't be, because I looked at the time. Yeah, I don't know what to say about that. Anyway, I will be back soon. Well, I just wasted a bit of time. It was 2:05 AM and the boards were where they are now basically. And dumbass me kept waiting and no more etched. So we've got some new solution in here. Goodness. Anyway, that is almost done. Won't be long now. See the copper running, turning to liquid. Pretty cool. Won't be long now. The last little bit's just going now. I had to move it over a bit because the fumes weren't all, they are now, but they weren't when it was over here all going up the fume extractor. I've still got to build a little bit of a hood for it. The airflow is not the best the way it is at the moment. Alright, we're good. Alright, I'll be back in a sec. Alright, that's another 2 boards. That's in fact the last 2 boards. Oh, that's not good. That got etched through a little bit. I mean, there's still plenty of copper there just because of how wide it is and the fact that it's only thin in the center and the fact that it's going to have solder over it, you know, but I still don't like that, you know. If I had have done those traces, like, how do I say this, you know, I was pushed for space and I did them really, really small, I would actually have to redo it because it wouldn't have the ampacity with what's left. Oh well. That's probably because I was cranking the heat up, trying to get the last of that ferric chloride to work. Well, I'm going to leave off here for tonight. I've got to pack the rest of this up, but I'll sort these boards out in the morning. I've done the 2 easy ones. I guess those are easy too. I mean, they're all easy, but the 2 quickest ones is what I meant to say. Anyway, that concludes this video. I am going to bed. It is now 2:39. I did say 10 to 2, so I guess that's what, 50 minutes, almost an hour on top of the time I planned on. Could be worse, I guess. Alright, well, if you enjoy my content, please give me a sub and a like, and I'll see you in the next video. Thanks for watching.